Okay, so I've been introduced. My name is David Weiss. I currently live in New York City, and I have taught in 4 different countries and learned 4 different systems for teaching and learning. There are a lot of similarities, there are a lot of differences. That tells me a few things about the culture of mathematics education, which I think is kind of important. This is a picture of your city from the air as I flew in. It highlights a misconception I had. I brought an extra sweater and some gloves and a hat and a scarf, and I've not used any of it. I thought for some reason there's going to be 2 feet of snow here. So I thought totally there was going to be tons and tons of snow. Well, it turns out I have lots of snow in New York. And so I thought, well, Kelowna is always colder than New York, so obviously there's going to be more snow. And so I really had a fundamental misconception about your weather. This is the snow that's left after an entire day of rain in New York, outside my front steps. And the reason why I'm starting with this story is it describes a problem in education, which is people start knowing things. They don't start empty. They start knowing things when they come to you. They have ideas about the world. And then you start teaching them. And it turns out most of the time they keep those ideas. Ideas are very persistent. You start teaching somebody and they keep the ideas they had before you started teaching them. And it's very hard to get people to change their ideas. I was going to maybe bring up something else. So think of knowledge as like a vast wilderness. Like you're wandering in the forest. That's knowledge. A map would be the curriculum standards. Formative assessment is the use of a compass to figure out where you are. It causes a feedback loop. It creates a loop where the teacher and the learner learn about each other's learning. Teachers ask a lot of questions. Anybody ever notice that? So I observed a teacher. He was in his first few weeks of teaching. He just sort of started standing up there. He asked 170 questions in a 40-minute lesson. That's 1 question every 23 seconds, on average. So then I did a calculation, and I said, okay, well, I taught in a classroom full-time for 10 years. I had 5 classes. I probably asked a lot of questions. I said like maybe 100 questions per class. That's 900,000 questions, which is relevant. Because if you've done something 900,000 times a certain way, it's really hard to change. I have a lot of practice asking questions. I don't necessarily have a lot of practice asking good questions. And the reason why questioning is important is it's part of feedback. So now imagine that learning is like a staircase. And there's a series of steps that you want the kids to go through to get to whatever the next level is. The kids have to go up the steps. You can't make it a ramp all the way up to the top. They've got to go up the steps themselves. So you have to think of questions that'll get the kids to go up the steps without pulling them up the steps or trying to drag them or making them skip steps. This is really hard. So questioning technique is really critical to formative assessment. We're going to do a couple case studies. You're going to get a chance to talk to each other about these. We had a group of teachers. They were given a pre-assessment task for their students. On average, 85% of their students mastered the pre-assessment. They were able to demonstrate mastery on the pre-assessment material. And 15% of their kids either got 0 or struggled, did not achieve mastery on the material. So here's a question for you. What do you do? I'm going to present these 3 options. Maybe you'll think of another. What do you do in this case? You've taught the material and almost all the kids get it. This is at the beginning of the unit, remember. This is a pre-assessment to the unit. So, talk to your neighbors. Decide. Introduce yourself first. Decide. What would you do in that situation? Okay, let's pull it back together. Thank you so much. How many of you have assessed your students at the beginning of a unit? Show of hands. Okay, of those people, how many people have found that their students knew a lot of what they were going to teach? A few times. If you were in this situation, what would you do? So, I'm going to do A, B, C, D, and D is like other. So A, reteach the Pythagorean theorem to everybody. I'm really pleased with this audience. B, move on to the next unit. Raise your hand high, be brave. We got a few people who just move on. Have the students apply the Pythagorean theorem in a rich math task. Okay, and I can show that you do, some of you say other. Other. Something else. Now you're going to have to tell me that. That's great. Okay, another case study. This is the end of the unit. You've given them a test. This represents a number of students who got each, sort of in each band, each 10% band. You guys all seen this good enough? You got a sense of what it looks like in your head? That's the distribution of the scores on the test. Now what do you do? Okay, talk. Okay, let's bring it back together. By the way, the thing I'm using to determine when to bring it back together is there's a slight dip in the volume as you think about what you're going to talk about now that you're done talking about this. And so then, not all of you are doing it obviously, but some of you are, and that's when I choose to jump in. That's formative assessment. Okay, so how many people would choose A? Just teach everybody. Exactly the same. I really like this audience. B, group students to discuss their different strategies. Who likes this one? We got a lot of people. Almost half. Split the class into two groups and presumably teach differently to the two groups. How many people? And other, something else. Okay, next case study. This is a pre-assessment. These are kids who are just learning multiplying. Sorry, let me amend that. Have never, ever seen multiplying binomials. This teacher gave the pre-assessment task. And he asked two questions. He said, multiply these two binomials, take your best guess at what you think the answer is, and then tell me how confident you feel in your answer. Now there's something problematic here that I have noticed a lot in my own teaching. I'd love to go back and change. Asking kids if they feel confident that they know something, I don't necessarily produces the information you want to be able to move on. So when you say, does everybody get it? And they all nod yes. There may be a problem there that you're not aware of, which is that they are confident that they know it. But the it is not the thing you want them to know. Okay, so pre-assessment task. What do we do? Discuss. Okay, let's pause there. I just have an observation. When I first saw that picture, it comes from a website called mathmistakes.org or .com, I don't know. You try both. And what I noticed is that I had seen that mistake after I had taught binomials, frequently. So then it made me wonder, did I change anything in the student?
What did one binomial say to the other? Rot spoil again.
Okay. So, who votes A? We got a lot of people, 50%-ish. Who votes B? Just don't make the mistake. Well, that's what I hear people doing all the time. C, give the students more practice problems. And other. We got a few others this time. By the way, people who raised their hand and said other, I don't know if you are paying attention to each other in the audience. If you aren't sure what other might be, I would track down somebody later who had their hand raised during other and say, what did you think? That'd be a good lunchtime conversation. Okay, moving on. So, John Golden, who does a job similar to what I do, but at a university level, he says that formative assessment involves basically 4 stages, and that you move through these stages, and he's got it in a circle here, but really it's kind of nonlinear. So you'll jump from one stage to the next stage and back again. Well, these are like the 4 different areas of thinking that teachers have to go through to be able to do formative assessment. You have to gather information. You have to evaluate your students. You have to figure out, well, what are my goals? Where are we going to go next with this information? And then you actually have to follow through and try it out. We're going to talk about the evaluation phase. So here, you have to decide, what are my goals and where are my students with respect to my goals? And this is, I think, a really important thing because I want to bring it up. There are 3 different concurrent definitions of mathematics that people use. The first one is that mathematics is literally the symbols and the vocabulary used if you're a mathematician or you're doing mathematics. So it's the symbols, it's the vocabulary. I know that this is a person's definition because they spend so much time talking about vocabulary. It must be what they're trying to teach. The second definition of mathematics says it's a set of standards or a set of content that you want the students to know. So mathematics is literally the quadratic formula, or it is linear equations, or it is fractions, or it is adding numbers. And then the third definition of mathematics is a process that we use to try to solve problems in this kind of vague area of logical reasoning and pattern finding and all of that stuff that we sort of associate with the process of mathematics. So we essentially have the symbols, the content, and the process. Well, those define your goals, right? So if you want the students to know the symbols, that's one of your goals. If you want them to know the content, that becomes your goal. If you want to know the process, well, that's your goal, and that informs how you teach. And the other thing you have to do when you're evaluating is be looking forward and looking back. So look forward to see where's the path for my students to get to the goals that I have for my students, whether they're symbols or content or process. And then look back to see what's the path they've been on already. What have they done already? So if you're a 9th grade teacher and you talk to the 8th grade teacher and you say, oh, you taught number lines last year, right? I don't think that's the BC grade 8 material. I've forgotten. But anyway, imagine you taught number lines in 8th grade, okay? And then 9th grade, you want to teach solving linear inequalities. And the person who taught number lines last year used a particular model. They said, well, we're going to draw the number line, we're going to draw a circle on the number, and we're going to count backwards whenever we want to add or subtract positive and negative numbers. And so then you say, okay, great, I know that you did that. So for the students for whom they cannot do the adding and subtracting of negative numbers, I should pick something else. I shouldn't do the same thing they've already had. Because it didn't work the first time. Why would you do it again? Planning. So this is the stage you go through to try to think through your goals and turn them into unit plans and lesson plans and worksheets and choosing the rich tasks for your students you want to do and what do you need to buy at the store. So you have the physical resources. These are all things I used in my math class at some point. Not every day. It's incredibly fun, by the way, to take a group of kids out of the park and have them put down cones and try to make sure their cones are in a right triangle. Right? So they have to verify using the Pythagorean theorem. And there's some experimental error, actually lots of experimental error, especially with 9th graders and cones and measuring tapes, but it's fun. Your classroom is one of your resources. So here, this is kind of a rhetorical question, but if you set up your classroom like this, what discussions are your students going to be able to have? How will they use each other as resources if this is your setup? And just a different remark, one that I hope keeps you all in business for the rest of your lives. This is not the classroom of the future, in my opinion. Okay, I don't want to see kids coming to school to sit in a classroom to connect to computers totally individually at all time. I love the use of computers. I think one computer for every 2 kids, and they should talk to each other when they're using it. So they get some feedback on the process. Just like if you gave them a rich problem, you put it in front of them, you wouldn't necessarily give one to each kid. You'd maybe want to force them to collaborate by giving them one piece of paper. So this is a better setup. The nice thing is you can pull it apart when you need to do that individual think time or to do the individual assessment, when you want to figure out where every kid is at by themselves. But it leaves the advantage that you can get the kids talking to each other. And how many people can give, this is another rhetorical question, how many people can give feedback when you're in the first setup? Really, one, you. And probably not asynchronously because you've got 30 kids. How many people can give feedback here? A lot more. So just in terms of feedback alone, this is a better setup. Obviously, it means that you have to change the materials you give. You have to give them things that are more interesting, that they're not likely to just copy from Johnny. And the other thing, of course, is there's a resource in your classroom of the students themselves and their interactions with each other. If you set up a classroom where kids talk mathematics, they're going to be more successful, especially learning the process. They're also going to be more successful learning the vocabulary, because they're going to need to use it to talk to each other. They're going to be more successful to learn the content, because when one person figures out the content, and I got it, they're more able to explain it to their neighbors, because they remember what they didn't get on the way to getting it. And then instruction, this is your job. So here's a math task. I want you to take a minute, just read through it, and for question 1, think of 2 ways you could solve this math task. Okay, now talk to each other about those ways that you thought of. Okay, let's just check. How many people were able to come up with 2 distinct ways of solving this problem? Just raise your hands. I have 2 ways that are different from each other for solving this. Let's hear some of those. Person in the back corner up there wearing the black sweater, I think. Set up a table. Okay, there's one method. Set up a table. Another method. Look for a pattern between the numbers, I guess. Okay. Another method. Sorry, say that again. Continue the diagram. So just draw the diagrams over again. That's 3. Another way. Yeah? Line graph. So plot a line that represents the data. Okay. Any other ways? Yes. Get out blocks and actually make it physically on their table, right in front of them. That's 5 so far. Other methods? Yes. An equation. So basically going to step 3 and coming back. That's cool. Okay, so we have 6 different ways, and it took us 2.5 minutes to brainstorm as a group. So I'm going to highlight 3 things here. The first is that this particular task is what we call a leveled task. Probably, if your kids can read at some level, they'll come in and be able to do question 1. They can do one of those 6 strategies. They'll find question 2 a little harder. They're going to have to extend their pattern or do something a little more advanced to get level 2 because it's not concretely in front of them. Then level 3, they're going to try to make an equation. Well, that maybe is a good goal for your students. If they can make an equation from this relationship, that's good news, right, if you're teaching them algebra. And then there are actually some problems on the other side, and they get progressively a little bit more challenging. And so one thing that this type of task allows you to do is to figure out along the learning progression, where are my students? So that's the first point about this task. The second point is, hardly any of you had your hands up when I asked you if you could come up with 2 methods by yourself. But with a group of people, you came up with 2 methods. So I recommend that if you want to uncover your students' thinking and think about what they may run into, you should talk to each other. You should collaborate. Teaching is hard. Don't do it alone. By the way, if we all did that as a profession, I think it'd be easier to ask for more time to work, to get more time to actually meet with each other if we were meeting to really improve our practice. I had a 3rd point, but I've forgotten. Oh well. Okay, so here's some actual student work on this task. So this is one student's work of 11,000 students who took this task this year in New York City. Take a look at it for a second. Well, a minute. Okay. We would normally take longer to do this, and we would interact more when we're doing it. This is what I lead teams of teachers through doing, looking at student work and trying to find evidence of their reasoning. Who thinks they know how the kid got question 1? It looks like they chose follow the pattern, which I remember somebody suggesting. What about question 2? A couple of us have an idea. When you guys hit question 3, did you pause and go, I wonder what this kid is doing? Because it looks kind of hard to tell. That was certainly my first reaction. Yes? So this is a really good point. So your kids have a successful strategy. They use it, and they get an answer. So the first is good. I mean, it's good they have a successful strategy. The second is, you said most of your kids. You didn't say all of your kids. So this would be a really good time to get kids who did different things to talk to each other. So you might end up looking like heterogeneous grouping, but there's always that kid off in left field who does something really interesting, who isn't necessarily like getting the A's. So you take this task and you group the students by the different solution methods they had. And then they would talk to each other and they'd say, counting takes a lot of work. I really like your pattern method. I'm going to do that next time. And maybe they'll use it the next time they see this task. The other thing is you would want to keep track of what methods they're using. So you know what methods they need to learn. Right? So if you're thinking of generic problem-solving methods, you have to think of, well, they know how to count tables. Some of them know how to do this. Some of them know how to do this. So having that list of possible things they could do at the beginning makes this a lot easier to plan for. And then now I want to go and find this kid and talk to them and say, what were you thinking for question 3? Because I don't understand. And I need to understand to be able to teach you. I need to understand your thinking because I need to know where you are. That was part of our thing at the beginning. No one jumped up and left and said, no, it's crazy to figure out where my kids are before I teach them. And I'm going back to questions for a second. We see a lot, I don't know, let's just take a guess here. Has anybody ever seen a show where people ask questions repeatedly and Jeopardy or 20 questions? This is from 1954, I think. There's a lot of quiz shows in the background where people ask questions that are very narrow, specific questions. They ask them quickly and you don't get a lot of time to think about it. Don't do that. That's not effective questioning technique. Instead, you want to aim for specific questions you have ahead of time that are going to prompt student thinking. Assessment. I've got to get over here. So, first off, you're looking for growth. There's a really interesting project that physics teachers do. They do something, I wonder if anybody's heard of it. They use it as part of testing to see if the way they're teaching is effective. So, thousands of physics teachers give this assessment at the beginning. It's called the Force Concept Inventory. They give it at the beginning to see what do kids understand about physics, so basically about an area of physics called kinematics. Has anybody here heard of the Force Concept Inventory? Have you given it to your students? Not yet. Okay. If you do teach physics, it's worth giving it. So they gave it to the students at the beginning, and they gave exactly the same assessment at the end, and they did not give students any specific feedback on those questions in between. They just taught. And at the beginning, students basically got about 6 out of 24 questions right, each of which had 4 responses. So that's about guessing. They didn't know very, very much. It was slightly higher than 6. Which says that they knew a little bit. They had some ideas. Then at the end, they gave the assessment again, and students would get 9 out of 24. That's learning, right? There's some growth there. What they discovered, though, is that interactive teaching methods, unlike the one I'm doing right now, where I'm talking at you, are more effective. In fact, interactive teaching, where the kids have to make sense, have to do rich tasks, have to do labs and projects, result in 3 to 4 times learning growth. So instead of 9 out of 24, we're talking 18 out of 24. A lot better. The other thing is that in your assessment, you're thinking about the future. it is tempting to say, I've got to reteach this. They didn't get it, so I've got to reteach. So I have a couple thoughts. One of which is, if you're teaching something and you have some other model that will help the kids understand, don't wait until after. Right? Give it to them right away. There's no reason to withhold your models. It's okay if kids have to make sense of something by thinking of 3 or 4 different models of understanding it. The second of it, this is kind of like when you talk to somebody that don't speak English, and you talk louder and slower. It doesn't work. Right? They're not more likely to understand you because you talked louder and slower again and again. The students in your self-assessment, and I described this to you briefly, right? If your students, you assess them and you discover that half the kids get it, that is now, 50% of the class is now able to act as a resource to getting it for the other 50% that aren't there yet. So sometimes you might do some stuff, and then after you've assessed the kids, you'd say, well, I'm not going to teach anything new. I'm going to make sure that I spend a period of time to solidify what they understand. And one of the ways I'm going to do it is present them with the same material, but let them talk about it more. And group them differently. And the very last point, this comes from Neil Postman's Teaching as a Subversive Activity. It's one of my favorite teaching quotes. Your objective is to cause change in your students, to take them from where they are and move them somewhere else. That's teaching. And if you don't move them, you didn't teach them. There may be a lot of reasons why that happens that are out of your control. I mean, lots of reasons why kids don't learn something. Maybe they're absent for the 2 weeks that they were supposed to be there. But formative assessment is a way of raising the odds that what they learn is successful.